Hi everyone, good evening to all of you. Uh, Welcome you all to this YouTube channel. And in this class, we are going to discuss organometallic chemistry. We will discuss some important PYQs of organometallic chemistry. First of all, before starting, now you can buy a 2-month subscription at Unacademy Plus in just rupees 2024. You have to pay only 2024 and you will get 2-month subscription. Because exam is very near, it's nearly 2 months, so you can prepare well for your CSIR net exam by using this new 2-month subscription, because earlier there was only 6-month 1 year subscription. This is a new add-on and it is only for you guys, so try to take benefit of this. And it is valid till April 20. Still you people can use my code SDSIR to join Unacademy Plus and using this 2-month subscription also. Let's start the session. Okay, we have done lots of questions in the previous session. We will start with this question. The greater stability of CS3 thrice C CS2 4 times titanium, this is a compound A, compared to that of compound B is due to. So this compound A is more stable than B. Why it is more stable? 4 possible reasons are there. Hyperconjugation in complex A, beta hydride elimination is not possible in complex A, steric protection of titanium, the stronger nature of titanium carbon bond in the complex. So try to guess the answer. If you know the concept, then you will realize the stability mainly depend upon beta hydride elimination. Beta hydride elimination, that tells about the stability. If complex can give a beta hydride elimination very easily, means the complex is very unstable. So we have to check in this complex titanium. We can draw this complex. There is a titanium and I can draw here titanium CS3. There is a titanium. One second. Yeah. There is a CS2. There is a carbon. CS3, CS3, CS3. So this is the complex. Here is a alpha carbon, here is a beta carbon. And on the beta carbon there is a beta protons. These are the gamma protons. So there is no beta proton, you can check. There is a 3-methyl group, but there is no beta hydrogen. There is no beta hydrogen. If there is no beta hydrogen, then the beta hydride elimination is not possible here. So no beta hydride elimination. Means this complex is stable enough, because the complex which do not show beta hydride elimination, they are very stable. So it is stable in nature. And we talk about the second complex, that is complex number B, that is titanium, CS2, CH and CS3, CS3. Although these kind of 4 moieties are there. Now this is alpha, this is beta. The beta carbon, this proton is beta hydrogen. So this complex has the beta hydrogen. And if have beta hydride, then it can easily give beta hydride elimination. It can easily give beta hydride elimination. So we can say that the complex A is more stable because it doesn't possess any beta hydride elimination, and complex B is less stable. So stability can be checked on the basis of elimination process. The complex which can give beta hydride elimination very easily are unstable in nature. So B is comparatively unstable as compared to complex A. As compared to complex A. Got it? Yes. Okay. Let's move to the next question. So B going to be the right option. Beta hydride elimination is not possible in complex A because there is no beta hydrogen. There is no beta hydrogen, so there is a nothing about beta hydride elimination. Nothing about beta hydride elimination. Other options are totally irrelevant. Hyperconjugation, then steric protection, stronger nature of titanium carbon bond. These are totally irrelevant options. So B going to be the right option. The oxidation occur very easily in case of there are the 4 different complexes. You have to tell which one give oxidation process very easily. You must know that 18 electron complex are very stable in nature. If any complex that does not possess 18 electron, means if any complex have 17, 16 or greater than 18, so they will show some kind of reaction. Either they can lose electron or they can gain electron, and they try to convert into a 18 electron complex so that they can become stable. For example, if there is a 16 electron complex, then complex will try to gain 2 electron and it will become 18 electron complex, and that will be stable in nature. Gain of electron is known as reduction. So 16 electron complex, for example A complex, gain 2 electron to get 18 electron. So means this complex A is showing reduction. Similarly, if any complex have, for example, let's say 20 electron or 19 electron, so these complex can easily lose 1 electron, 2 electron, and this can lose easily 1 electron to convert into a stable 18 electron complex. So these complexes will go for reduction oxidation process. Oxidation process. They are asking oxidation occur very easily in case of. In which case oxidation take place? We will say that the complex which possess more than 18 electron will give oxidation very easily in order to convert into a stable 18 electron complex. So we have to calculate the number of electron in each given complex in A, B, C, D options. In option A, iron, it contribute 8 electron. There is eta 5 C5 H5 twice Cp, cyclopentadienyl. It has hapticity 5, so it will contribute 5 electrons, and there are the 2 C5H5, means we can say that 5 into 2 plus 8. So there will be 18 electron. There will be 18 electron in this complex. Second one, there is cobalt. Manganese, iron, cobalt. Cobalt will give 9 electron, and there are 2 Cp, 5 into 2, means the total will be 19. Here you can check ruthenium. Ruthenium is a member of iron family. You can remember by the term ferrous. So it will contribute 8 electron and 10 by these 2 Cp ring. So there are again 18. In the last complex, cobalt, that will show 9, and there is a 2 Cp, 5 into 2, 19, but there is a one positive charge, we will minus 1. So there are 18. These 3 complexes have 80 electron. They will not going to show any oxidation reduction, but the complex B having 19 electron, 1 electron greater than 18 electron. So this complex can easily lose 1 electron and convert into a stable 18 electron complex. You can see after losing 1 electron it will convert into complex D. It will convert into complex D. So B going to be the right option. B going to be the right option. You can check. Yes. B going to be the right option. Let's move further. Okay, we have done it already. There is a compound FeC9H8O3 that shows one signal at 2.5 ppm part per million, another one at 5 ppm in proton NMR spectrum. IR spectrum gives the two bands around 1900 centimeter inverse and 1680 centimeter inverse. The complex follow 18 electron rule. The correct statement is it has one CP group, it has terminal CO, it has CS3 ligand, it has iron hydrogen bond. तो क्या चीजें भैया जी यहाँ पे होने वाली है वो चीजें आपको डिस्कस करनी है. सबसे पहले आपके पास फॉर्मूला दिया FeC9H8O3. FeC9H8O3. Okay. What you can do? FeC9H8O3. There is one CP ring. CP means C5H5. C5H. So there is a one iron. This connected to CP ring. C5H5. Now, if we subtract C5H5, so there will be 4 carbon and 3 hydrogen and 3 oxygen. Yeah, this will be. You can check out. In the question, you can see IR spectrum of showing two bands, one around 1900 and one around 1680. So this 1900 band correspond to terminal carbonyl group and 1680 correspond to bridging carbonyl group. Means this complex must have two carbonyls. One is terminal in nature and one is bridging in nature. So you can see one is terminal and one must be bridging in nature. You can just check out. Yeah. Here, so there is a one CO must be there as a terminal and one should be bridging. But how can a bridging CO attach there? There is no another metal, so CO will be connected like this. COCS3. Now there is one more CO like this. You can check. Here you will see one is iron. There are 5 carbon C5H5, 2 CO, and there is one CO that is bridging and one CS3. You will check the formula will be same. 5 carbon is here, 6, 7, 8, 9. So 9 carbon and hydrogens 5 and 3, 8. 8 hydrogens there and 3 oxygen. So formula is correct and we got one CO that is bridging in nature. This is bridging in nature and it will give a IR value. It will give a peak in IR around 1680 centimeter inverse. And although these two are terminals in nature and will give peak around 2100 centimeter inverse. You can memorize if there is a free CO, free carbonyl group, that will give peak around 2143 centimeter inverse. And terminal CO gives peak around 2100 to 1850 centimeter inverse. This range for terminal CO. Although there are some other factors on which this frequency depends, like which kind of group are there in the neighbor of this carbonyl, but the major factor is either they are terminal or they are bridging. That is the main thing. Second one, there is two type of bridge. There can be mu2 bridge, mu2 CO. The carbonyl bridge to two different metals. They are two same metal, that doesn't matter. If one carbonyl bridge to two different groups, we will say it mu2 CO. And its value lies in between 1850 to 1750 centimeter inverse. Last one, mu3 CO. Its range 1750 to 1650 centimeter inverse. So this value, you can say 1680 value tells about the bridging CO. So that's why there is one bridging CO. And although we can also discuss the data of NMR, it's showing this complex give the two signal, one signal at 2.5 ppm and one at 5 ppm. So all five protons gives one signal, and this CP group, the proton attached to CP, will give the signal around 5 ppm. So these 5 hydrogen give one signal in proton NMR spectroscopy, because all the 5 protons are equivalent in nature, and the equivalent nature are due to the rotation of this 5-membered ring. You can say this 5-membered ring is symmetrical with respect to iron. Yeah. Okay. You may confuse with one term, that is fluxonial, but the fluxonial term will not arise here. Fluxionality arises if this metal joined with only one carbon. Out of this 5 carbon, if the metal joined with only one carbon, in that case fluxionality come in the role. Because if that ring joined with one carbon, so that carbon number can change on the rotation. Firstly, the metal can join with carbon number 1, then it can join with carbon number 2, then carbon number 3, carbon number 4, due to that kind of rotation. But in case of this eta 5 CP, all the 5 carbon joined with the metal iron simultaneously. Okay, that's why all the 5 hydrogens are equivalent in nature. If you take eta 1 CP, although there is the same NMR spectra, all 5 hydrogen give one signal, but the reason for both are different. In case of eta 1 CP, the reason is fluxionality of the ring. The ring rotate around the metal. Once it will join with carbon number 1, then join with carbon number 2, then join with carbon number 3, then join with carbon number 4. That is fluxionality. But in case of this eta 5 CP, all the 5 carbon join to metal simultaneously. Okay, so you can see. Let's move to the options. Yeah. It has CP group, eta 5 CP, yes, correct. It has terminal CO, yes, it is correct. It has CS3 ligand, no, there is no CS3 ligand. Although there is CS3 attached to CO, so the ligand, actual ligand is COCS3, because CS3 is not directly joined with the metal. So CS3 is not the ligand here. The actual ligand is COCS3. This statement is wrong. Last one, it has FeH bond. FeH कोई बॉन्ड यहाँ पे है नहीं, और वैसे भी जो मेटल हाइड्राइड की बॉन्ड होती है उसका जो NMR स्पेक्ट्रा आप देखोगे नेगेटिव में आता है, -2, इट्स स्टार्ट फ्रॉम -1 to -50. माइनस में रहती है वैल्यूज, वो बहुत ही ज्यादा शिल्डेड नेचर का होता है, दैट्स वाई उसकी वैल्यू बहुत नेगेटिव में रहती है, ठीक है ना, क्योंकि मेटल के पास में बहुत सारे इलेक्ट्रॉन की डेंसिटी रहती है, या तो आप चीज देख सकते हैं वही डेंसिटी आपकी आती है, उसकी वजह से ही जो रहेगा बेसिकली दैट विल गिव the value in negative in proton NMR spectra. So D is the incorrect one. We will go with the statement A and B. A going to be the right option. A going to be the right option. Next one. The reaction of NiCO4 with ligand L have two options, PMe3 or POMe thrice yield NiCO3L. The reaction is, you have to tell about the which kind of mechanism is there, which kind of reaction is there. NiCO4 with the ligand L. NiCO4 with the ligand L. So this is a 16 electron complex, you can see 16, is it 16? No, you will check, it is not 16. And nickel, if you check about the nickel, here nickel in zero oxidation state, because all the CO are neutral. If nickel in zero means it will D10 configuration, so it can't be square planar, it can't be square planar, it will be tetrahedral in nature. It will be tetrahedral. We will show it like this. It has the 18 electron. Iron, cobalt, nickel contribute 10 electron, and total electron contributed by the all 4 CO. So there will be 18 electron. 18 electron complex gives this kind of reaction with the help of which one? Associative? No. Dissociative mechanism. 16 electron gives the reaction by associative mechanism, and 18 electron complex gives the reaction with the help of dissociative mechanism. Dissociative mechanism. So here the right answer will be B, dissociative mechanism, because it is a 18 electron complex. Here you can see there is some twist in the question, because if by any chance if you made it square planar like this, which is not possible, but if you made it like this square planar, then square planar complex will give associative mechanism. Square planar have vacant orbitals above and below, and square planar tend to give associative mechanism. But we know that this is not the actual structure, this complex is not the square planar in nature, so that's why there is dissociative mechanism. Dissociative. Getting? You can check out. Next one is, the following will not undergo oxidation addition by the methyl iodides. Which of the following will not undergo oxidation addition by methyl iodides? Oxidative addition by methyl iodide. You have to know that in oxidative addition, oxidation state increase by 2. If any complex have +1 oxidation state, that will convert into +3. If any complex have +2 oxidation state, that will convert into +4. Okay. So that complex can easily give oxidative addition which possess oxidation state lower than stable oxidation state. For example, if any complex is +3, the stable oxidation state, and any complex possessing +1, so that can easily give oxidative addition. Oxidative addition. There is 2 less than the stable oxidation state. Complex must possess 2 less than the stable oxidation state. Stable oxidation state. You can check out the option D will be the right answer. It will not give oxidative addition. If you check out, the titanium will be in +4 oxidation state, and it is the maximum oxidation state of titanium, so it will never raise its oxidation state beyond 4. So that's why it will never give oxidative addition reaction, because it will never extend the oxidation state beyond 4. You can see. So D going to be the right option. D going to be the right option. You can check. You can check out. Okay. So D going to be the right option. Some people try to use 18 electron rule here, and they will make a big mistake here, because the complex may or may not show 18 electron rule, that have nothing to do with this kind of concept. So you must have the knowledge of oxidation state. That is a main parameter of oxidative addition. Oxidation means the complex must increase its oxidation state, and that will be increased by number 2. Number 2. +2 to +4, +1 to +3, 0 to +2. If complex metal already in maximum oxidation state, so that will not give any kind of oxidative addition reaction. For example, if by any chance titanium is in +3 oxidation state, can it give oxidative addition? If by any chance, if titanium in +3 in this kind of complex, can it give oxidative addition? We will say no. This complex of titanium in +3 oxidation state will not give any oxidative addition, because in oxidative addition, oxidation state increase by number 2. So if we increase 2 from +3, so it will be +5, and +5 is not possible for titanium. +5 is not possible for titanium. So D going to be the right option. You can check out. Okay. So these are some basic questions. Actually, I am really sorry for today. There was some technical issue, and that's why the class was very late. So we will finish it now, and I'll take the special class a day after tomorrow, and that will be a 2-hour class starting from 7:30, because actual timing of this class is 7:30 p.m. but due to some technical glitch we conduct it at this 10:15, 10:20. So that's why we are going to finish it now. So like the session, and there is a one offer that I talked about earlier. This one, crack CSIR 2024 2-month subscription. This is a special add-on on your demands, because there are the 2 months left for CSIR net exam approx. So this is going to be a better choice at this particular time. So you can use the code SDSIR and you will get the maximum benefit of this 2-month subscription. Also you can take any 3 month, 6 month, 1 year subscription. They are already there on the app, but this is a new one, and this is valid up to April 20. Okay, so thank you very much. Keep watching, keep learning. Like the session, and if you have any doubt, comment below in the section comment box. If you have any query regarding the classes, regarding the courses, you can check out the description box of the class. You will get lots of knowledge about the classes, class timing, special class link, and plus courses link will be there. And there is also a Telegram channel link, so you can join our Telegram channel, and we will update about the classes, about any kind of exam vacancy on that particular group also. So thank you very much. Keep watching, keep learning.